People develop their own work practices after using a wide variety of manual and computer tools. Groupware can only be accepted if it supports continuity with existing individual work environments. Seamlessness is the key issue because users frequently move back and forth between individual and collaborative modes. We designed TeamWorkStation to realize a seamless shared workspace. It supports real-time and distributed collaboration. The first prototype was implemented in 1989. Let's have a look at a design session using TeamWorkStation. 2 CCD video cameras are provided at each workstation, one for capturing live face images of the member, and the other for capturing the desktop surface image and hand gestures. 2 users are now discussing the system configuration by annotating printed diagrams by hand. The key design idea of TeamWorkStation is translucent overlay of individual workspace images. TeamWorkStation combines 2 or more translucent live video images of computer screens or physical desktop surfaces by using a video synthesis technique. Translucent overlay allows users to combine individual workspaces and to point to and draw on the overlaid images simultaneously. TeamWorkStation provides 2 screens, the individual screen and the shared screen. These 2 screens are continuous in video memory. This multi-screen architecture allows users to move any application program window between the individual and shared screens just by mouse dragging. Therefore, it is easy to bring your own data and tools in each personal computer into the shared workspace to use in remote collaboration. Hard copy information can also be easily shared by just placing it under the CCD camera. TeamWorkStation provides a seamless shared workspace in which participants can freely use a variety of everyday media, such as computer tools, handwriting, printed materials, and hand gestures simultaneously. Through many experiments, we realized that TeamWorkStation achieves cognitive seamlessness by allowing users to keep using their favorite individual tools while collaborating in a shared workspace. One problem of the overlay approach is that the results of collaboration cannot be shared directly. We mainly used a video printer or videotape recorder to record the results and the collaboration process. Let's take a look at a calligraphy teaching session with TeamWorkStation. The student uses computer software called Mac Calligraphy to generate Chinese characters on the shared screen. Student strokes are displayed in black. The instructor watches the student's real-time strokes via the shared screen and makes necessary comments by using a brush with red ink on the paper on his desktop. The instructor can make his comments directly over the student's strokes when the student deviates from the suggested forms, and the student gains the immediate feedback of the teacher. Through these calligraphy experiments, we realized that the most important feature is that all of the collaborators share not only the results of drawing, but also the dynamic process of drawing and pointing. We also applied TeamWorkStation to a remote consultation involving machine operation. The scenario runs like this. The operator asks the remote support division for help. The expert checks the control panel status by looking at the video image sent from the branch. To explain what the operator should do, the expert overlays a diagram stored as a computer file onto the live video image. Now, let's take a look at a design session using a TeamWorkStation 2 that is a new version implemented in 1992. We redesigned TeamWorkStation to make it easier to use. The system configuration was simplified based on the feedback from test users in NTT. We have introduced a new multi-user interface technique called Clear Face. Clear Face is the translucent live face images over shared workspace. The serious weakness of the original TeamWorkStation was the restricted shared screen space. To solve this problem, we devised Clear Face. In Clear Face, the entire screen can be used as shared workspace. Experiments confirm that users have little difficulty in visually separating the drawing layer objects from the translucent face layer. Another interesting observation is that all subjects hesitated to draw over the faces. When they drew figures or wrote texts on the shared drawing spaces,